All right, at this point, we are ready to do pretty much any modeling we want. So let's take a look at our output data. And let's say I wanted to look at a job description and the text and the responsibilities and the qualifications and predict what kind of category that job was in. Let's give that a shot and see how we do. All right. So we've got, I believe, 23 different job categories that we could choose from. So let's run a prediction algorithm for that, and we'll just set one up for each of these and see how they work. So we've got our data set ready to go. And if we're using the split holdout approach, we'll just build our standard modeling pipeline, split data. We can use we'll start with a multi-class logistic regression. So that'll be our modeling technique. We'll train our model. And then we will score and evaluate our model. We're going for category, so our label column will be category. All right, so for multi-class logistic regression, we can go with the defaults here. Enter your random number seed. For split data, we'll go 75%. Enter our random number seed, or your random number seed. We'll use append the score, and then we'll evaluate the model. I think we're good to go. So at this point, we can run it and see how things look. Okay, we've run our model. Let's see how it did. And we've got an overall accuracy of 0.82. We've got micro and macro precision, micro and macro recall that we can use to calculate our F1 score. All right, so again, when we get a multi-class classification model, we don't get the AUC and the rock charts. But if I double click and just take a look at my outputs, I can get a little bit more information. So here I'm going to go and look and see what my confusion matrix looks like. In here I can see across the different job categories that we were working with how well we did, and then I could then do a little bit of additional analysis based on that. All right. So now, at this point, we could then, because we do have lots of features, let's just take a look at those features again. So for the scored data set, yeah, we've got 23,000 some odd columns. And for our holdout data, we have the 300 some rows. And we would have to scroll way over to the right to see our scored data set, which doesn't even show up because this only shows a certain number of rows and columns. All right, so we would have to download this and then bring it into some kind of a text editor for additional analysis. Now, ML Studio can work with it just fine, and then I could put it into my production environment and start creating my predictions. But let's say we wanted to reduce the number of features or find just those that are most important. So we could use filter-based feature selection right up in here before we split the data. Of course, now we know that filter-based feature selection is a somewhat simplistic approach in that it uses just correlation. The other thing we could do is bring in our PFI pill after we've built the model and see which features are most important. We could do a little bit of feature selection that way. Let's go ahead and add that to our pipeline. So we'll take our trained model, and our holdout data, run a PFI on it. And while we're at it, we could probably just go ahead and do all of this. I'm going to just copy these for now. I don't need the select columns again, so I can get rid of that. All right, so at this point, I can, of course, I would customize all of my pills so that I know what's going on and which model I'm using it for. But just for this exercise, I'm going to submit this job and see what we end up with. While our other two PFIs are finishing, we can take a look at our evaluate models and just see how they did. So overall accuracy 0.82, precision 0.82 to 0.79, recall 0.82 to 0.76. So let's take a, that was our n-grams. If we look at the LDA model, all right, our accuracy is not quite as good. Quite a bit worse, so as well as our precision and recall. And let's see what happened with our feature hashing. .79, so somewhere in between, and that makes a little bit of sense because with our extract n-grams, we're actually using all the features as is. With LDA, we're trying to cram them into a certain number of topics, and still incorporate as much information as we can. I think it would probably be better to add a few more topics to this, maybe get it up to 7 or 9. That may put us more in the ballpark with LDA. And then with feature hashing, we end up with a fair number of features as well and get pretty close to what we had with our accuracy. And then precision and recall might even be a little bit better. Let's see what we had for those two, for those other two. Maybe not. Yeah, a little bit worse. So anyway, that gives you a feel for how that works. Now let's take a look. Well, this one's been running for quite some time and the PFI is not done on this particular model. So in this case, we've got, let's take a look at the results data set. We've got 23,028 columns, including our labels. So that's 23,027 features. So PFI is going to take a while to run through those. So that's just something to keep in mind. Now we have smaller feature sets in our other two models over here, and the PFI has finished for both of those. So let's take a look at this one here. This is our LDA model. So that one only had 5 plus our original features to evaluate. And we could see here title, the job title and job location actually were the most informative, followed by topic 5, which was moderately informative, topic 2, topic 3, topic 4, then topic 1 was the least informative. But all of them contributed somewhat to the performance of the model. So we didn't have any negative PFI scores here that would indicate we want to eliminate that. If we look over here we're working our way with the feature hashing, and I think we had actually changed it down to 9, which gave us yeah, 1,540 columns. We had 3,000 plus when we had left the feature hashing bit count to 10 as it comes by default. All right. So if we go and take a look at the feature importance of this feature hashing one, the PFI, we can see here that some of our features, our hashing features, end up being the most informative. These three in particular, hashing feature number 177, number 502, and 163, followed by a whole bunch of these other hashing features that all have the same score. And that takes us down, I think, yeah, to the bottom of this list. So we could then export the whole data set to see exactly which features may actually hurt our model. Now, selecting and pulling out features when you have a large number of features like this ends up being a time-consuming back and forth effort. In most cases, when you have text processing, you generally keep all the text features and use them, but you may find some reasons where you could take a look at your feature performance using PFI and fine-tune your model a bit. All right, so that's it for this video, and that's it for our text processing videos. Hopefully you found these informative. We'll move back to the reading and see where that takes us next.